As I look at this integral, I see that I have powers on trig functions, but I'm used to products and it's a quotient. But that kind of leads me to think, you know what, maybe I will still try that strategy. Since I have this odd power of sine, I'm going to split one off and try and write everything else in terms of cosine and see what we have. So if I split one of these off, I have sine squared x over cosine x, and then a sine x dx. And then I'm going to express this in terms of a cosine using the Pythagorean identity. So this would be 1 minus cosine squared x over cosine x, and then sine x dx. Now what I would want to do, and why I am doing this, is I know that if I let u be cosine x, the derivative of that is negative sine x dx. I'm splitting this sine off, I have the sine x dx part. So let's try that and see what we get. So we have u equal cosine x, and then du would be negative sine x dx, and I have the sine x dx part, so I can put the negative here and replace sine x dx with negative du. So let's go ahead and do the substitution. I'm going to put the negative out in front of the integral. This would be 1 minus u was cosine x, so this would be u squared over u, and then the du. So looking at that, I see that that's now going to be something that's easy to integrate. It's a fraction, and I can go ahead and split that up and put the u under each piece. And then I can do the integration. So this would be negative natural log absolute value of u. And then this negative and this negative will make a positive 1/2 u squared plus a constant. So the last step would just be to resubstitute now and replace the u to get something in terms of x. So I have negative natural log of the absolute value of cosine x plus 1/2 cosine squared x plus a constant.